series. We're back on mathematics today, and absolutely fundamental. We're talking about short division, something that we use in Key Stage 1, Key Stage 2, Key Stage 3, daily life. It's something that we really need to get right. Looking at the flip chart that I've just built for this one, absolutely fundamental to all mathematics, not just for passing tests, not just for your arithmetic, but for word problems. It is one of our 4 operations: adding, subtracting, dividing, multiplying. We need to get this correct. There is a long division version. We're not going to go through that today. Stick to short division. It's all you need to know. Please do spend time learning this. Multiple marks available if you're interested in marks, and it is a hugely key skill. My memorable line for today is, don't forget your toolkit. I will draw you out the toolkit shortly so you know exactly what I mean. But please don't think we're too good. We can do it without one. Just make sure we're doing the basics correct. You won't drop any marks and you'll get everything accurate almost every time, or a lot more of the time. Here are a couple of example questions from the 2022 Key Stage 2 SATs arithmetic paper. Lots of people get tripped up by the fact that the missing box, the answer box, is on the left-hand side. We're used to saying something like this. If you need to draw it out again, that's absolutely fine. It doesn't make the calculation any different. We set out our short division, divisor there, nice straight lines like you would with a ruler, not like mine. Give yourself space as well. Normally recommend writing one number in one box, but that would make my writing tiny in this example, so I won't be doing that. And what I mean by a toolkit is write down the times table of your divisor, and then you won't have to hold it in your short-term memory. 32, 40, 48. Probably leave it there. Just do a few items. Your working memory is really important because for people who like computers, it's like your RAM. It's what you have to hold in your head. Some people are really good at holding numbers in their head. For some of us, it becomes really confusing when we try to hold on to too many things at once. You can make some notes on the paper. You don't have to hold it in your head. So working through this calculation, how many times does 8 fit into 2? It doesn't. We're going to exchange the 2 over, leaving us with 24. How many times does 8 fit into 24? We might know it, or we can go over here to our toolkit once, twice, 3 times. It's a terrible 3. And then add the 0. The answer there is 30. You can put the answer up there if you'd like to. If you actually put the 0 at the beginning, it makes no difference. 0, 3, 0 is still 30 again. Next question was literally the next question in the test paper, is 840 divided by 5. Write it out the same way, again with your nice sharp ruler lines, unlike mine. Use your toolkit if you need to. Maybe you don't need to for 5s, but I would recommend you just have it there. It doesn't take very many seconds. 30, 35, 40. Okay, how many times does 5 fit into 8? Once. How many have we got left over that we need to exchange? 3. So we move it to there, leaving us with 34. How many times does 5 fit into 34? Toolkit time. 1, 2, 3, 4, 5, 6, and no more. So 6. And we then have that 4 that we haven't done anything with. Push that across and exchange that. We now need to calculate how many times 5 fits into 40. Use your toolkit again. 1, 2, 3, 4, 5, 6, 7, 8. 168. And you're done. You write it in the answer box and you're absolutely finished. You might not think you need your toolkit for your 5 times table, but it took me seconds to write it. I didn't have to hold anything in my head, and I didn't make any silly errors, like, for example, thinking that you could fit 5 7 times in 34, or just something silly where you're going to drop that singular mark and you just don't need to do it. So again, don't forget your toolkit on the side. Again, write a toolkit. It's very important. I'm going to show you some different ways of representing remainders now. It's not always going to end up with just a nice round number like our 30 and 168. Same method as before. How many times does 6 fit to 2? It doesn't. Exchange the 2 across. Toolkit, 6, 12, 18, 24, 30, 36, 42. If you're not sure on these, you can just add them. You can do a quick column addition there. So how many times does 6 fit to 25? 1, 2, 3, 4 times. Exchanging 1. How many times does 6 fit into 17? 1, 2, not 3 times, so twice, up to 12. Now we can get up to 12, so our remainder now And the usual way we represent it is like that. 42 remainder 5 being our answer. We just leave the remainder hanging up there. However, there are other ways we can represent that remainder. That's usually fine to do that. The question will usually tell you if it wants it represented as a fraction or as a decimal. I'll show you how to do those now. To write remainder as a fraction, it's the exact same calculation here, so we can do this relatively quickly. How many times does 6 go into 2? 0. 4 times in there with 1. Twice in there. Now we would have a remainder of 5. To do a remainder as a fraction, just draw that on top and turn that into a fraction. 5/6. It will always work. You use your remainder, put it on there. 5/6. If you think about it, if there was one more, if that 17 was an 18, we wouldn't have a remainder at all. So we've got 5 left over. As soon as we get to 6 left over, we can fit another 6 in there. So the answer to this would be 42 and 5/6 if the question asks for your remainder as a fraction. So just drop that on top of your divisor at the beginning and then actually represent your answer like that. Remainder as a decimal now, same calculation. This is going to be a little bit longer across the page. 6 fits into 2 no times, exchange the 2. How many times does 6 fit into 25? 4 times with 1 left over. And then how many times does 6 fit into 17? Twice. Would have 5 left over. Now, usually we leave the 5 hanging up here as a remainder. But now what we're going to do is create a place for that remainder to go. So 257 is the same as 257.0. I haven't changed the number here. I've just created a new column, the tenths column. Instead of putting that remainder up there, I'm going to drop it there. So that becomes 50, or the equivalent of 50. We will need our toolkit: 6, 12, 18, 24, 30, 36, 42, 48. We might need further than that. How many times does 6 fit into 50? Once, twice, 3, 4, 6, 7, 8. We still have another remainder. We got to 48. We have 50, so we need to exchange the 2 somewhere. Create another column. 257.00, you're not changing the number, you're just creating another column into the hundredths. How many times does 6 fit into that? Fits in 3 times. And again, we have a remainder of 2. You might notice this is going to be a pattern. It would carry on forever. And you can quite reasonably stop after maybe 2 decimal places. Your answer would be 42.833. And if you want to show that it's going to recur forever, put a little dot over the top of that. Just to check with the calculator, 257 divided by 6, 257 divided by 6. And there's all the 3s that we could have done and gone on forever, but we're not going to do that. So there's a few ways to represent short division. Short division with a decimal, put decimal points in, create a place to actually drop your remainder into. Short division with your remainder as a fraction, put it on top of your divisor and then write it in a neat package, 42 and 5/6. Or you can just write it as remainder R5, whatever you need. One extra thing over here, when we have this calculation down the bottom, exactly the same, something I see quite a lot, happening quite a lot is, how many times does 6 fit into 2? No times. And I see people then exchanging that 6 into there. I don't know why, but we need to consider this structure here, the short division bus stop as they call it, impenetrable. No number should be able to get through that line. So we're not going to be bringing that 6 into play at all. We're only going to be exchanging numbers that are in this little pocket. We're going to be exchanging the 2 over there instead of the 6. So that's a common error that is made. Hopefully that's helped you understand short division a little bit more. Again, this is just one page of an arithmetic paper. There's 2 marks. It can be done really quickly, even when drawing out a toolkit. It doesn't take very long, but it is fundamentals. I will do another video where our divisors will be 2 digits, or double digit division as I call it. I'll also go through some word problems as well, but this is a real fundamental one that we need to get right. If you have any other videos you want me to make or any other topics you're particularly stuck on, as ever, let me know and I will make you a video as soon as I can. See you soon.